Hey guys, this is Joel Kumar Sen and you're watching Joel Kumar Sen English YouTube channel. So guys, in this video I'll share with you from question number 141 to question number 160, right? So before telling that, let me tell you about our test series, that is NLC test series, right? We have launched the test series for NLC GET, right? Especially for this examination. We are providing two test series for non-technical, right, as well as technical. For technical section, we are providing 10 full length tests, and the price for this technical portion is only 149 rupees. And for non-technical portion, my dear, we are providing 65 plus test, only 299 rupees. The link for both the tests are given in the description, and for technical portion is in the description as well as, my dear, in the first comment for your ease. You must get the test series for practice and see where you are basically standing among all the students we have. So let's start. Question number 141. A body at 500 Kelvin cools by radiating heat to ambient atmosphere maintained at 300 Kelvin. When the body has cooled to 400 Kelvin, the cooling rate as a percentage of original cooling rate is about. So my dear, here we have to find out what percentage. In this case, we have one question, that is theta by theta naught multiple what, my dear, 100. All right. Now, so theta naught is what, my dear? Theta is what? T1 minus T infinity. Power would be what, my dear? 4, and in the denominator T naught power 4 minus T infinity power 4 multiple what, my dear? 100. All right. So T1 is what, my dear? 400 to the power 4 minus 300 to the power 4. In the denominator, what we have? 500 to the power 4 minus 300 to the power 4 into what? 100. All right. So now we have to solve this, and I am giving you task, my dear. Solve this problem and tell the answer in the comment box what answer you are getting among all the options. Write down question number and an option, the correct answer according to you, in the chat box, in the comment box, obviously. So let's go for the next question, that is 142. Fraction of radiative energy leaving one surface that strikes the other surface is called. So my dear, suppose that we have surface 1 and surface 2. This is 1 and this is 2. It is striking the surface 2. That means it is what? F21. So it is what, my dear? View factor, right? So it is also known as what, my dear? Shape factor. View factor or shape factor, both are very important topics for examination point of view. For many examination I have seen question, especially this question already asked in ESC. Question number 143. Consider the following statements in the respect of automobile engine with thermosiphon cooling. Which of these statements are correct? So we have to, my dear, find out among all these statements we have given, which of these statements are correct. So let me first read. Statement 1. Heat transfer from gases to cylinder walls takes place by convection and radiation. That's correct. Next, most of the heat transfer from radiator to atmosphere takes place by radiation. No, my, it is not correct, because it is happening most of the time, it is happening because of convection, not radiation. Third, most of the heat transfer from radiator to atmosphere takes place by convection. That's correct. Fourth, heat transfer from cylinder walls takes place by conduction and convection. That's correct. That means 1, 2 and 4 are correct. So if you'll find the answer, my dear, 1, 2 and 4, 1, 2 and 4. So 1, 3 and 4, because 2 is wrong, right? So 1, 3 and 4. Yeah, option B is the correct answer for this question. Question number 144. What do we have given? Two sphere A and B, same material, have radii 1 meter and 4 meter. Temperature 4000 Kelvin and 2000 Kelvin respectively. Which one of the following statements is correct? The energy radiated by sphere A is, we have to find out energy radiated by sphere A, right? So we know that, my dear, what we know basically, that is E is equal to sigma A T to the power 4. So we have to basically find a relation between EA and EB. So what we can write basically, EA division EB is equal to sigma A is what, 4, because sphere is there, 4 pi r square, A means 1 square, multiple T means 4000 to the power 4. Division sigma 4 pi multiple r square, 4 square multiple 2000 to the power 4. Alright, now cancel all these things, my dear. So what we are getting basically from here, that is 1. So what we can say, my dear, energy radiated by sphere 1 is equal to that of sphere B. So option C is the correct answer for this question. Question number 145. For an opaque plane surface by irradiation, radiosity and emissive power are respectively 20, 12 and 10 watt per meter square. What is the emissivity of the surface? We have to find out emissivity of the surface, right? So my dear, we know that what? We know that radiosity J is equal to what? Epsilon EB plus 1 minus epsilon G. Alright, J is equal to what, my dear? That is radiosity is, we have given 12 is equal to epsilon, we have to find out EV is what, my dear? Emissive power is 10 plus 1 minus epsilon multiple G is what, my dear? That is irradiation, that is 20. Now we have to solve this. Alright, so 12 is equal to 10 epsilon plus 20 minus 20 epsilon. Alright, so what we can get basically, if we'll solve it, let me solve it. So what we're getting basically, if we'll send these two to this side, then we can write 10 epsilon is equal to 8, epsilon is equal to 8 by 10 is equal to 0.8. Therefore option C is the correct answer for this question. Question number 146. What we have given, two long parallel surfaces, each of emissivity 0.7, are maintained at different temperatures and accordingly have radiation exchange between them. It is desired to reduce 75% of this radiant heat transfer by inserting thin parallel sheets of equal emissivity 0.7 on both sides. What would be the number of shells? We have to find out what would be the number of shells, right? So we know that, my dear, Q, we have first we'll write down Q with shield and Q without shield is equal to 1 by n plus 1. Use this trick, my dear, to save lot of your time. On the upper person what we have given, that is with shield. On the lower person what we given, that is without shield. It is saying whenever we are using shield, its heat transfer rate is decreased by what? 75%. So remaining heat transfer is what? 25%. 25% means what, my dear? 0.25 Q. Division Q is equal to 1 by n plus 1. Is this what, my dear? 1 by 4 is equal to 1 by n plus 1. So n is equal to what, my dear? 3. Therefore option C is the correct answer for this question. Question number 147, right? The earth receives at surface radiation from the sun at the rate of 1400 watt per meter square. The distance of center of sun from the surface of earth is 1.5 into 10 to the power 11 meter. The radius of sun is sun multiple 10 to the power 8 meter. What is approximately the surface temperature of the sun, treating the sun as a black body? So my dear, this is an amazing question. So it is saying, my dear, what it is saying, this is what my dear, we have sun, this is another surface. This is what, my dear, it is saying 1.5 into 10 to the power 11, and sun, its radius is what, my dear, 7 into 10 to the power 8 meter. So what we can basically do, we have given heat transfer rate what per meter square. So we have to first convert into what we know that E is equal to E by A is equal to what, sigma T to the power 4. So we have to find out T. We have given A, we have given E, but we have given E per meter square. So we have to convert that into E first. So let me write 1400 multiple area, that would be what, my dear, that is very important, 4 pi, distance mean it is radius 1.5 into 10 to the power 11 square, division area multiple also sigma, because we can say this with sigma multiplication is equal to 2 to the power 4. So what we are getting here, area is again 4 pi because sphere, right, r square 7 multiple 10 to the power 8 whole square multiple sigma 5.67, Stephen Boltzmann constant 10 to the power minus 8. Now T is equal to what, my dear, the value we are getting from here, power 1 by 4. So what is the value we are getting? Let me solve it and let me tell you the answer of this question. Just give me some time so that we can solve this question quite easily and you will get answer of this question. Alright guys, so what we're getting basically, that is 5800.2. So we can say that option C is the correct answer for this question. Question number, my dear, 148, right? What is saying, a hemispherical surface 1 lies over a horizontal plane surface 2 such that convex portion of the hemisphere is facing sky. What is the value of the geometrical shape factor F12? We have to find out the value of the geometrical shape factor 12, right? So my dear, we have given like this. All right, so let's consider this 2 and this one is what, 1, because it's saying hemispherical surface 1 lies over horizontal plane 2, right? We have to find out what, my dear, F12. That is important. We have to find out F12. So we'll use here what, my dear, summation rule first. That is what, F22 plus F21 is equal to 1. So F2 is equal to what, my dear, 0. So F21 is equal to what, my dear, 1. Now we'll use reciprocity theorem. A1 F21 is equal to A2 F12, right? A1 F21 I will written A1 F12 is equal to A2 F21. This should be like this, right? This is reciprocity theorem. So my dear, we have to find out what F12. So F12 is equal to A2 by A1 multiple F, what, my dear, A212, that means F21. So F21 is what we have given, that is 1. So A2, that is 2, A2 2 means pi r square, right? This should be what, 2 pi r square because hemispherical, so half of the sphere. This cancel out. What are you getting? Half. Half means what? Option B. You will see option B is the correct answer for this question. Question number 149. What we have given? A small sphere of outer area 0.6 meter square is total enclosed by large cubical hall. The shape factor of hall with respect to sphere is 0.004. What is the measure of the internal side of the cubical hall? So again, very simple question, but it's an amazing question, I must say that. From this question you will learn something at least. All right, so what again we have given, my dear, we have to find out measure of the internal side of the cubical hall. So we have given small sphere, it is enclosed by a cubical shape. All right, so let's say what we can do, basically we have to use the concept of what, that is shape factor of the hall with respect to sphere. Hall with respect to sphere, let's say this is 2 and this is 1. So we have given F21 is equal to what, this much. Now we'll use summation rule. F11 plus F12 is equal to what, my dear? 1. F11 is equal to plus F12 is equal to 1. So F1 is equal to what, my dear? 0. So F12 is equal to what? F1 is equal to 0. So F1 is equal to what? 1. Now we'll use reciprocity theorem. What is saying, my dear? A1 F12 is equal to A2 F21. What we have to find out, my dear? That is F21. So F21 is equal to what? A1 by A2. A1 is what? Sphere 4 pi what, my dear? We can say that we have given already the value, that is 0.004, right? We have given, no, sorry, it's say we have given, that is 0.6 we have given area. Division A2 is what, my dear? That is cube, so it will be 6a square. All right, so F21 we have given. Now we have to find out A. Now we have to simplify this and find the answer of this question. So A is equal to what, my dear? We are getting root under 25 is equal to 5 meter. That means option B is the correct answer for this question. Question number 150, right? This is an amazing question. We have given to find out. We have to do what, my dear? Match the list. Matching list question, I must say that, and this is a very good question. So whenever we're getting matching list question, write down A, B, C, D. Right, now we have to what do, my dear? We have to find out. That is very important. What do you have to find out? We have to find out. That is very important. Yeah, what do you have to find out, my dear? That is with which one, A, B or C, D, I am really familiar. Then we have to look at the matching answer. Which one I am really familiar, then I have to, my dear, what? I have to match the answer, right? So what we can do, basically, let me share with you. That is very important. Okay, so is there? Yeah, it is working. So radiation heat transfer, it is happening because of what, my dear? Wien's displacement law. That means A is 2. B, conduction heat transfer, it is dependent on what, my dear? Fourier law. B is 3. Whenever you find out two answers consecutively, then always look at the options we have given, which is matching. As you can see, C is matching. No need to go ahead, my dear. Just mark the answer and go. Don't need to solve further this question. Go ahead, right? Mark the answer. Go ahead. But here we are solving, so I will share with you, my dear. Force convection. That means what? Stanton number. And the transient heat flow. That is what? Fourier number. So option C is the correct answer for this question. Question number 151. Intensity of radiation at a surface in perpendicular direction is equal to. We know that intensity of radiation I is equal to what, my dear? E by what? Pi. So as you will go, yes, product of what? Emissive power of surface multiple and 1 by pi. Product means what, my dear? Multiple. So option C is the correct answer for that question. Question number 152. What is the shape factor of a hemisphere body placed on a flat surface with respect to itself? So it is just simple question, but let's say this is 1 and this is 2, right? It is saying with respect to itself. That means we have to find out F22. We know that F11 plus F12 is equal to 1. So this one will be 0. So F1 is equal to what, my dear? 1. Again, we know that A1 F12 is equal to A2 F21. How do you know this about, my dear? How we can say this? Because from, my dear, what is that? That is the concept of reciprocity theorem. From that we can say this. Now A1 is what, my dear? A1 is very important. Even F12 is equal to what, my dear? 1. So we have to find out what? F21 from here. F21 is equal to what? A1 by what? A2. A1 by A2. A1 is what? Pi r square. And A2 is what? Hemisphere. That means half of the sphere. 2 pi r square. So it is what? 0.5. We have to find out F22 because question is saying that to find out. So what we can say? F21 plus F22 is equal to 1, my dear? 1. So F2 is equal to what, my dear? That is 1 minus 0.5 is equal to 0.5. So option C is the correct answer for this question. Question number 153, which is really important. What is the value of the shape factor for two infinite parallel surfaces separated by a distance of? Right. So let me share with you. Two parallel surfaces we have given. All right. So in this case, what will happen? 1 and 2. So it is saying what will be F12 is equal to what? So we can say that F11 plus F12 is equal to 1 from summation rule. So F1 is equal to what, my dear? 0. Therefore, F12 is equal to 1. So option C is the correct answer for that question. Question number 154. Good question. Let's see what it is saying. If the temperature of a solid surface changes from 27 degrees centigrade to 627 degrees centigrade, then its emissive power changes which ratio? So we know that E is equal to what? Sigma T to the power 4. Sigma T to the 4. So we can say that E1 by E2 is equal to T1 to the power 4 by T2 to the power 4. T1 is what? So from here we can find the ratio, right? So 27 plus 273 division 627 plus 273, and power would be what, my dear? 4. So what we are getting basically, let me tell you, that is what we have done basically, E1 by A2. So it should be what, my dear? 1 by 81. So it is matching with what? Option D, because we can do that E2 by E1. So option D is the correct answer for that question. Question number 155. We have to match it. Match list 1 phenomenon with list 2 number, law, factor. Select the correct. Okay, so matching question. So we have to write A, B, C, D. What do we have? That is, let's see here. Radiation heat transfer. It is, my dear, what? View factor. Conduction transfer, Fourier's law, right? And force convection, that you can say that what, my dear? That is standard number, you can say that, right? And my dear, that is what? Tangent heat flow, that is 1. Biot number. In general study in whenever we study about themes and all these things, we study about this thing. So option D is the correct answer for this question. Again, my dear, the same tree you can apply. After finding out 2, always match with the options. Most probably you will find the answer and you will save half time of your, and you can invest that same time in other question to solve the difficult question, right? Question number 156. What is the basic equation of thermal radiation from which all other equations of radiation can be derived? So what is the basic equation of thermal radiation? We have to find out basic equation of thermal radiation. That is what? Planck's equation. From Planck equation we can derive other laws or other things of the radiation. So that is what? E lambda B is equal to 2 pi C square H lambda to the power minus 5 division E to the power CH upon lambda KT. So option B is the correct answer for this question. Question number, my dear, 157. For a hemisphere, the solid angle is measured in radian and its maximum value is pi. So my dear, let me tell you, for solid angle we measured, my dear, what? Measured by steradian, and we measured this by what value? 2 pi. So option C is the correct answer for this question. Question number 158. What is the radiation intensity in a particular direction? So we have to find out the that means definition, right? Let's read option A. Radiant energy per unit time per unit area of the radiating surface. Wrong answer. This is not the option. Current radiant energy per unit time per unit time solid angle per unit area of radiating. No, it is not. It is like that, but there is some problem. I will tell you that. Option C. Radiant energy per unit time per unit solid angle per unit projected area. Yes, there should be projected area of the radiating surface in the given direction. So option C therefore is the correct answer, because it is saying the correct definition of it. Question number 159. What is the equivalent emissivity for radiant heat exchange between a small body with a large body enclosure? So my dear, let's say this is a small body and this is the large body. Small body. So 0.4 emissivity. So definitely it will radiant 0.4 only. That means let's say 1, 2. So equivalent emissivity, how much will be there, my dear? That is 0.4 only. So option B is the correct answer for this question. Question number 160. The heat exchange between a small body having emissivity epsilon 1 and area A1, a large enclosure having emissivity epsilon 2 and area A2. So my dear, here you can say that is what? A1 is very small than A2. Then only even that is possible. Let me write the formula of this. If you write the formula of this, my dear, please look at the formula. You can imagine it why I am saying this. This is very important for you to know, right? So let me write the formula. Sigma is equal to A1 sigma T1 to the power 4 minus T to the power 4 division what, my dear? 1 by epsilon 1 plus A1 by A2 multiple 1 epsilon 2 minus 1. So it is so, my dear, as we have given in this question, that what will happen, my dear? All these things will be neglected. So epsilon 1 will go upper side. So we can write this formula. Therefore option C is the correct answer for this question. Thank you very much for watching, my dear, this video. So my dear, must go for this NLC test series. Amazing question will get. You will get self-confidence after writing test series. So 65 plus tests we're providing in non-technical part because most of the technical students lack in this part. So we're providing 299 rupees only, and for technical that is also amazing, 10 full length tests, and we are providing only and only for 149 rupees. You must go for it. Thank you very much for watching. Bye bye. See you soon. And like this video, share with your friends, and God bless you all.